Hello guys, hope you're doing well. In this video, we will learn how to integrate even powers of tangent and cotangent. For example, the integral of tangent squared x dx, or the integral of tangent to the fourth x dx, and so on. The main idea is to use these identities. Tangent squared x equals secant squared x minus 1, and cotangent squared x equals cosecant squared x minus 1. Right? Now let us start with the first example, the integral of tangent squared x dx. We use the identity tangent squared x equals secant squared x minus 1. So we have the integral of tangent squared x dx equals the integral of secant squared x minus 1 dx. So we have the integral of secant squared x dx minus the integral of 1 dx. As you know, the integral of secant squared x equals tangent x, and the integral of 1 dx equals x. So the integral of tangent squared x dx equals tangent x minus x plus c. Now let us move to second example, the integral of tangent to the fourth x dx. We can write the integral of tangent squared x times tangent squared x dx. Now we replace one factor of tangent squared by secant squared minus 1. So we have the integral of tangent squared x times secant squared x minus 1 dx. If we expand, we have the integral of tangent squared x times secant squared x dx minus the integral of tangent squared x dx. For the first integral, let tangent x equals u. So if we take the derivative of both sides, we have du equals secant squared x dx. So we have the integral of tangent squared x times secant squared x dx equals tangent of x equals u. So we have the integral of u squared times secant squared x dx equals du. So if we use the power rule, we have 1 over 3 u cubed plus c. So we have the integral of tangent squared x times secant squared x dx equals 1 over 3 u equals tangent of x, means 1 over 3 tangent cubed x plus c. And we already know that tangent squared x dx equals tangent x minus x. So finally answer equals the integral of tangent to the fourth x dx equals tangent cubed x over 3. Look at this formula, minus the integral of tangent squared x dx minus tangent of x minus x. So we have tangent cubed x over 3 minus tangent of x plus c. Or the integral of tangent to the sixth x dx. So we have the integral of tangent to the sixth x dx equals tangent to the fourth x times tangent squared x dx. Now replace tangent squared x by secant squared x minus 1. So we have the integral of tangent to the fourth x times secant squared x minus 1 dx. Now if we expand, we have the integral of tangent to the fourth x times secant squared x minus dx minus the integral of tangent to the fourth x dx. For the first integral, we have the integral of tangent to the fourth x times secant squared x dx. So let u equals tangent of x. So if we take the derivative of the both sides, we have du equals secant squared x dx. So we have the integral of tangent of x equals u. So tangent to the fourth x equals u to the fourth times secant squared x dx equals du. So if we use the power rule, we have 1 over 5 u to the fifth. And u equals tangent x. So the integral equals 1 over 5 tangent to the fifth x plus c. And as you know, the integral of tangent to the fourth x dx equals tangent to the fourth x dx equals this expression, right? So we have the integral of tangent to the sixth x dx equals tangent to the fifth x over 5 minus tangent cubed x over 3 minus tangent of x plus c. The integral of cotangent squared x dx. We use the identity cotangent squared x equals cosecant squared x minus 1. So the integral of cotangent squared x dx equals the integral of cosecant squared x minus 1 dx. And this integral equals the integral of cosecant squared x dx minus the integral of 1 dx, right? And as you know, the integral of cosecant squared dx equals negative cotangent x, right? So we have the integral of cotangent squared x dx equals negative cotangent x minus the integral of 1 dx equals x plus c. The integral of cotangent to the fourth x dx. And we know that the integral of cotangent to the fourth x dx equals cotangent squared x times cotangent squared x dx. And we know that cotangent squared x equals cosecant squared x minus 1. So we replace one factor of cotangent squared x by cosecant squared x minus 1. So we have the integral of cotangent squared x times cosecant squared x minus 1 dx. So if we expand this expression, we have the integral of cotangent squared x times cosecant squared x minus dx minus the integral of cotangent squared x dx. In the first integral, let u equals cotangent x. U equals cotangent x. So if we take the derivative of both sides, we have du equals negative cosecant squared x dx. So the integral of cotangent squared x times cosecant squared x dx equals u is cotangent x. So the integral of u squared times cosecant squared x dx equals negative du times negative du, right? So we have negative u squared du, and if we use the power rule, we have negative 1 over 3 u cubed plus c, and u is a cotangent x. So the integral of cotangent squared x times cosecant squared x dx equals negative cotangent cubed x over 3 plus c. So this integral is negative cotangent cubed x over 3, and we know that the integral of cotangent squared x equals negative cotangent x minus x. So the final answer equals the integral of cotangent to the fourth x dx equals negative cotangent cubed x over 3 minus negative cotangent x minus x plus c, or negative cotangent cubed x over 3 plus cotangent x plus c. The integral of cotangent to the sixth power is solved in the same way, so I will leave it to you as a practice problem. In the next video, we will talk about the integral of odd powers of tangent and cotangent. See you soon.